Good day, ladies and gentlemen. Today we want to look at bones of the upper limb, and we begin with the humerus. Now you know the humerus, the layman will call it the arm bone, bone of the arm, or funny bone. Now let's look at the features of the humerus. The humerus presents with a rounded head which orients medially, and it has what we call it greater tubercle, which is laterally oriented and at a higher level than another tubercle known as lesser tubercle at a lower level. In between these two tubercles is a groove or sulcus known as intertubercular sulcus. Now this intertubercular sulcus can also be called bicipital groove. The reason being that the long head of the biceps brachii muscle tendon passes through this groove. Again, just away from the head of the humerus is an oblique groove. This oblique groove represents the physical line, which used to be the physical plate, the glowing end of the bone. Now, below these tubercles is the surgical neck. Just below the tubercles, we have the surgical neck, the so-called because of its susceptibility to fractures as far as the humerus is concerned. Beyond that, we have the diaphysis or the shaft of the humerus. Now the shaft of the humerus proximally is cylindrical in shape, but as we descend distally, it flattens and assumes a triangular shape. Now, on the proximal shaft of the humerus, there is, on the lateral aspect, there is a triangular shaped roughened area known as deltoid tuberosity. It is so called because of its shape, triangular shape, as well as the insertion of the muscle, deltoid muscle. Now, opposite to the deltoid tuberosity will be the insertion for the brachialis muscle. Now, at the posterior aspect of the proximal shaft of the humerus, is a radial groove. Now this radial groove, as a result of transmitting the radial nerve, is also known as radial groove. Not only the radial groove is admitted here, but also the profunda brachii artery, the deep artery of the arm. Now, at the inferior aspect, the lower portion of the shaft, anterior aspect of the shaft of the humerus, provides attachment to the brachialis muscle. Now, distally, the bone, you can see that distal aspect appears to be like a bow tie. Now, this bow tie are the modified condyles of the humerus. Laterally, this condyle is shaped like head and therefore is known as capitulum. So that's the lateral condyle of the humerus, known as capitulum. Now the medial modified condyle is shaped like pulley. So this pulley shaped structure that you see here is known as trochlear because of its shape. Now, above these modified condyles are some fossae. Above the capitulum is a shallow fossa known as radial fossa, and this fossa admits the head of the humerus during flexion of the elbow. The opposite one, which is a bit larger and found on top of the trochlea, is known as coronoid fossa. Now it is so called because it admits the coronoid process of the ulna during flexion of the elbow. Now, above these condyles are some other processes. So it depends on the orientation they are given, either lateral description or medial description. The one which is more prominent and located above this modified medial condyle, because it's oriented in the direction of the head, is known as medial epicondyle, very palpable at the elbow. The less prominent one, which is located just above the capitulum laterally, is known as lateral epicondyle. Now, emerging upwards superiorly from these epicondyles are some ridges. So just like for orientation's sake, if it is coming from the lateral medial epicondyle, then we are going to call it medial supracondylar ridge. The opposite one, which emerges superiorly from the lateral epicondyle, is known as lateral supracondylar ridges. Now, when we get to the opposite aspect of the distal aspect of the bone, there is a single large fossa. And this single large fossa admits the olecranon of the ulna during extension of the elbow. Now, there are several features which we'll be looking at as far as the osteology and myology is concerned. So we'll look at that one. Now, the next bone we want to talk about is the radius. Now, how do you know it's the radius? You get to know that because when you look at it proximally, at the proximal aspect, its head is shaped like a car tie. Now, if it's a car tie, then it assumes a circular profile for which we can determine the radius of this figure. Now, so proximally, the bone has this circular head with a pit at its superior aspect known as fovea capitis. Now, just below the head, we will find the neck of the ulna, and somewhat anteromedially placed, is the radial tuberosity, a roughened area. And you know, the biceps tendon will insert here. Now, below it, we can see that the bone tends to flatten somewhat flattens, and therefore we have some other lines, prominent lines, that we can also appreciate. Now, because this is the lateral bone of the forearm, it has articulation with the medial bone of the forearm by way of a membrane between these two bones known as interosseous membrane. Therefore, that area which provides attachment to the interosseous membrane, because there is a lateral bone going to articulate with the medial bone of the forearm, this interosseous border will be medially oriented. Now, when you look at it again, still on the shaft, you can see there's an oblique line, and that is what we call as anterior oblique line, because this is the anterior aspect of the bone. Now, the posterior aspect of the shaft, you also find the posterior oblique line, because this is the posterior aspect of the bone. Now, getting to the distal aspect, anteriorly, the distal aspect appears smooth. It's smooth. but the posterior aspect, you can see it's roughened. Now, the most prominent rough projection that we see, which we can see here, is known as Lister tubercle, and because it's found on the posterior aspect or the dorsal aspect of the bone, we can also call it dorsal tubercle. Now, this dorsal tubercle is very important for this reason. Now, on the lateral aspect of the dorsal tubercle, there are two tendons which are tied there. That is extensor carpi radialis longus and extensor carpi radialis brevis. On its medial end, there is an attachment to a bone. There is attachment to a bone. Sorry for the orientation. This is actually the medial aspect of the bone, and there's the lateral aspect of the bone. Because there's, lateral bone, there's supposed to be the medial aspect. So this is where the lateral, extensor carpi radialis longus and extensor carpi radialis brevis will insert. Now, at the other side, just medial to the dorsal tubercle, provides insertion to the EPL, extensor pollicis longus muscle. Good. Now, when we get to the medial aspect of the distal aspect of the bone, there is a facet, an articular facet, and this is for articulation with the head of the ulna distally. And when we look at the inferior aspect of the bone, we can see two articular facets. Now, the one which is laterally placed provides the surface articulation point for the scaphoid, and it is triangular shaped. The quadrangular aspect, the one which orients medially, four-sided in shape, provides surface for attachment to the lunate, and these bones are bones of the wrist, carpal bones. Now, therefore, one thing that we talk about is that although we know that the radius is shorter than the ulna, but when we talk about articulation with the wrist, bones of the wrist, it is only the radius that does the articulation by way of the scaphoid laterally and then lunate medially. Now, there is the reason why the ulna does not play a role in formation of the wrist joint is that there is a triangular fibrocartilaginous complex which is known as articular disc, which separates the ulna from the carpal bones. Now, the tracheotomy may only partake in the formation of the wrist joint during ulnar deviation of the wrist. So when you deviate the ulna, that is the only time that the tracheotomy will partake in the formation of the wrist joint. Now, there is another process on the distal aspect laterally, and that process is known as the styloprocess of the radius. Styloprocess of the radius. Now, for the ulna, the ulna is the medial bone of the forearm, and if someone should, how would you know that that's the ulna? When you position the bone this way, proximally, you see that it has a U-shaped structure. Ulna is spelled with the letter U. So this bone, just like the humerus as well as the radius we've seen, is also a long bone. Remember that we said that long bones will undergo endochondral ossification. Now, this bone proximally has this topmost process very prominent, known as olecranon or olecranon process. And this olecranon process orients anteriorly. Now, the inferior process that we see, which is crown shaped, is known as coronoid process. Now, the coronoid process and the olecranon process both contribute to the formation of this notch known as trochlear notch. Now, because this is the medial bone of the forearm, it articulates and therefore articulates to the lateral bone of the forearm radius. There is a proximal articular facet, and this is for articulation with the head of the radius to form the proximal radio-ulnar joint. Now, when you look at the shaft, somewhat anteriorly placed, is another roughened area, just like what we saw in the case of the radius. This is known as ulnar tuberosity, and it's for the insertion of the tendon of the brachialis muscle. Now, when you look at the shaft, because there is a medial bone of the forearm going to articulate with the lateral bone of the forearm, what happens is that, and there is a point of attachment at their shafts by way of the interosseous membrane. The shafts laterally placed, will be the interosseous border for the ulna, and that is essentially what we see. But you realize that as you descend distally, the bone tends to thin out, in diameter and in circumference, and at the end of the day, it gives us a neck, a constricted neck, and a distal head. So remember that this one, the head orients distally. Now, located posteriorly will be another process, and this process, in the living, is shaped like pen, so we call it styloid process, or you can say it's rod shaped, and that is called styloid process. Now, for the bones of the wrist is organized into two rows. We have the proximal row and the distal row. Now, the proximal row, there's this mnemonic: some larvae take positions that they can handle. So some, that's S for scaphoid, lateral, from lateral to medial proximal row. Larvae, L for lunate, then T for triquetrum. Now you can see on top of the triquetrum is another bone sitting on top of it. Now, unlike the other bones, which are generally described as short bone, this bone, which is known as pisiform, is actually a sesamoid bone, because this bone is found in the tendon of flexor carpi ulnaris. Sesamoid bones will find themselves in such tendons, and they will tend to stabilize, those muscles and joints. Now, at the distal aspect, from lateral to medial, so we've seen some larvae take positions for scaphoid, lunate, triquetrum, pisiform. That's trapezium, the trapezoid, cant, capitate, that's the largest carpal bone, and H, hamate. And this hamate has a hook, and this is known as hook of hamate. Now, in the hand, we have the palm, bones forming the palm, and then bones forming the digits or the fingers. Those forming the palm are known as metacarpals because they go beyond the carpal bones. Meta means beyond. Metacarpals. Remember that the carpal bones are actually 8 in number. We saw 2 rules, proximal rule of 4, distal rule of 4. The metacarpals are 5 in number, numbered from the radial side, that's where the thumb is located, through to the ulnar aspect, to the little finger. So this is metacarpal 1, 2, 3, 4, and 5. Now these metacarpals are known as miniature long bones. We've seen these long bones, ulnar, radius, humerus, but these are known as miniature long bones. In fact, as well as these phalanges are known as miniature long bones. Now, is it about the size that we are calling the miniature long bones? Yes, the size plays a role, but then again, they have only one functional epiphysis. Now, unlike what we've seen so far, you should have 2 epiphyses, but with the metacarpals and phalanges, they have 1 functional epiphysis per bone. Now, for each bone, whether being metacarpal or being phalanx, what happens is that they present with what we call proximal base, intermediate shaft, and a distal head. Now, normally for all these metacarpals, we expect that their epiphysis is actually at the head end of the bones. Okay, so we expect that we said they should have only 1 epiphysis. They are supposed to be at the heads of these bones, except the first metacarpal, whose epiphysis, functional epiphysis, it's at the base, because that's where its ossification, secondary ossification center is. And that is why some anatomists believe that the first metacarpal doesn't really, have the features, or shouldn't even consider it to be a metacarpal. It looks more of a phalanx. The reason being that the phalanges, yes, they will have proximal base, intermediate shafts, and distal hairs. But they are functional epiphysis, and therefore where the ossification, secondary ossification takes place, is located at their bases, which is in agreement to that we see in the case of the proximal of the first metacarpal. So these are it. When you take the thumb has 2 phalanges. The rest of the digites have 3 phalanges each. So for the thumb, you have a proximal phalanx and a distal phalanx. And then for the remaining digites, you have proximal phalanx, intermediate phalanx, and a distal phalanx. Now, you realize that there will be, that kind of articulation between the carpal bones. We've seen the scaphoid and lunate with the radius, forming the radiocarpal joint. Similarly, if it's between the distal root bones of the carpals and the metacarpals, then you have what? Carpo-metacarpal joint. And then if it's between the metacarpals and the phalanges, metacarpo-phalangeal joint. But those between phalanges will be known as interpharyngeal joints. Remember that there will be only 1 interpharyngeal joint in case of the thumb, but there will be 2 in case of the rest of the digits. Now, if there are 2, then we will have proximal interphalangeal joints and distal interphalangeal joints. Now, we've seen that for the radius, we are going to see, we are going to look at, we've seen that proximal there's articulation, proximal radioulnar joint, distal there's articulation,